Hey there, everyone. My name is Ryan Schul. Welcome to my data science channel. Thanks for dialing in today. So, in the lesson today, I want to talk about house price indexes and what are they and what are they used for. Okay, so basically, we can collect data on home value, home prices or home values changing over a period of time and see, is the trend for one neighborhood or one city up? Is it down? Is it sideways? What direction is it going? Okay, so that's what the lesson is going to be about today. I think it's pretty interesting. I like real estate and pricing, valuation, and things like this. Okay, so basically, I found this data online. If I show you the website, I'll take you over there just for a sec. You can scroll down to the bottom and you can see the data source over here. Okay, so everything came from here. Or is it this one right here? Okay, so if you copy and paste that into the browser, you will get all the data. Okay, so you can download the code. I'm going to share all the code with you guys, and this comes from over here, CSV. So right, so just click on this little thing over here, and you'll have all the data you need. And my inspiration for putting this together was actually this thing. I found this recently, came across this thing. I thought it was very interesting. You have all kinds of information from the Federal Reserve Bank of New York about house prices and how they change over time. So if we click this little play button, you can see based on the shading of the different counties. These counties are defined by FIPS codes. Okay, so a county and the FIPS code is basically the same thing. As far as I can tell, I mean, I think it's basically the same thing. So that's how we can define different regions where people own their homes or even rent their homes, right? And this is for New York State, and it's kind of cool. You can actually mouse over this thing and you can get the details. So if I go over to Bronx, I put the mouse over there, you can see that's Bronx, that's Queens, that's where I live. This is Kings County. Over here is Staten Island, or Richmond, I guess. What is this? Staten Island. This is Manhattan over here, and so on and so forth, right? So let me stop that. And it's pretty cool. You can go upstate here. You have Clinton, Franklin. Over here, I think is Niagara. Yep, that's close to Niagara Falls. Over here is Oswego, Oneida, right? So it's all upstate New York, and I think they have. You can change this little slider over here, and you can see the updates of the color coding, and the lightness and darkness correspond to the increasing or decreasing house prices over time. And I think this is for the whole country. Yeah, this is for the whole country. So I think this is pretty cool. You can see how prices are um, fluctuating over time, either increasing or decreasing. So I think the map is very interesting and very useful. Unfortunately, it looks like there's a bunch of missing data. Everything that's white over here appears to be missing. I could be wrong about that, but it looks like it's missing. So I'm not sure what happened there. But I think probably at least half of these are filled in, which is pretty neat, right? So that was sort of my motivation to replicate this kind of map and do it in Python, right? We're gonna put together all the code in Python and build our own map over here. Okay, so I went to that website that I just showed you and downloaded the data. And I have a couple little notes over here, like why we would be interested in doing this stuff, right? For macroeconomic trend analysis, real estate market trends, homeownership versus renting decisions, mortgage and risk assessment, right? So risk management. If you work for a bank and you're issuing loans to home buyers, this kind of information could be very useful, right? Urban and rural housing trends, impact of policy changes, right? So changing legislation, taxes, regulations, things like that. So understanding all of this stuff, I think, is very useful and very practical too, right? So I downloaded the data here. I'm reading it into this data frame. So pretty standard PD, read CSV, right? Pandas comes from over here. There's our friend Pandas. I think I use this for every single lesson that I demonstrated to you guys. I think Pandas and everyone, and NumPy is in most of them. Those are probably the two most important lessons. Libraries in Python. Pandas and NumPy, and SciPy is pretty common too, at least for the type of work that I do, right? So here's the data. This is what it looks like. HPI type, flavor, frequency. So this comes out monthly. This data is monthly, and all of this is going to be different, right? Some of these things come in monthly, sometimes quarterly, sometimes just yearly. I think GDP, I think, comes in yearly. The Fed or Fred collects that data. I've got a video on that. I'm gonna put that out in just a little bit here. And then you see the place name. So this is essentially the the city. Some of these are cities, some of these are states, and then they have a place ID and then the year. Okay, so you can see how this is changing over time. Oh, this is interesting. So this actually comes in monthly. It starts monthly, and then it switches over to quarterly at the end, right? So this is the head of the data frame, and then this is the tail, or at least for Puerto Rico, they get it quarterly. So here's the quarters, 1, 2, 3, 4, right? And here's the months. It goes from 1 up to 12 per year, right? And this is the changing house price, right? So that is very useful because if we just look at the price, say that's just a point in time, it's called a PIT, point in time data point. If you look at the trend over time, then you can see how these housing prices are increasing or decreasing or going sideways, right? So I think it's pretty interesting to look at this type of time series analysis and see how these house prices are changing. So we go ahead, do the import. It comes in, the date comes in as a string, first of all. So I'm going to convert that to an integer, and then I'm going to sort all of these so they go in order, right? So it's either ascending or descending. Well, we want it in ascending order, actually, right? Because we're looking at the price change over time as time increases, right? As time changes. So that's the first thing. Do a simple conversion, and then I'm going to put that into a Plotly chart and plot this. And because this is an animated Plotly chart, I can look at the changes of home prices by state over time. Okay, so this isn't the county data that we saw before or the FIPS data, but we'll get to that in just a moment. But I think this chart is pretty interesting. It's dynamic, it's interactive. You can zoom in, or you can see the details. There's New York State, that's where I live. And this is all very useful. Now, this other data over here was pretty cool because you actually have it at the state level, right? Where is it? There's New York, okay? You can see the change in prices over time when you click this. So we're going to try to reproduce that. So we have two views at the entire state level. So this is an average of the entire state. Is the average house price increasing or decreasing? That is very useful. But there's so many regions within the state. There's so many counties and there's so many cities and even neighborhoods within cities that it's not as useful as we would like it to be, right? Just to see the change in house prices by state is a good start, but we really want to get more granular than that, right? Okay, so house prices across the state are going to change with different frequencies. Some might be slower, some might be faster, some might be appreciating, and others might be depreciating, right? Even within counties, you see all the counties outlined over here. Okay, this I don't even know, in New York, probably 20 something counties in New York. So each one is going to be different too. And even within the county, the neighborhoods are going to be responding differently to housing price changes too, right? So you can have some appreciation, and right across the street, the house can be depreciating. So looking at it on a macro level for the entire state is somewhat useful, but we really want to get more granular and get more details so we can get this at the FIPS level or the county level. Okay, so I looked online, I found some FIPS data over here. So I'm pulling that from this JSON, doing a GET request to fetch the CSV file. Okay, and this is the source of the CSV file, and we get cities. Okay, so we get GDF of cities, and I'm going to go ahead and display that. Let me go ahead and run that right now. I'll display that, and then I'm going to go ahead and pull out the FIPS data and get the geo ID, is short for geography ID, state FIPS, and then county FIPS. All right, so this is how we're getting that more granular type of data that we're drilling down into a deeper level to get more useful information about all of this, all these housing price changes at a micro level, right? So this is the macro level over here. This is the big picture, but we want some more details. So I just ran that, and this is what I get. Okay, so I get city, state, population, latitude, and longitude. So you can see we had the states before. That's useful. Now we're getting the population data, and we're getting latitude, longitude data, right? So that is useful for many reasons. Over here, we have about 50 rows because we have 50 states. Now, because we're drilling down to a much deeper level and getting a lot more granular here with this request, we get quite a few more rows. This is the count of rows, 3,221 rows with 10 columns. And then from there, when we do the merge over here, so we're merging these together, right? We have DF merge, which is the data frame HPI. This is the housing price index data, right? And that is merged with all of the geography data over here. Okay, so if you look closely, df merge, I can copy and paste that and show that to you guys. Control C, Control F. Then you can see the highlight over here, how everything gets merged together. Okay, so this is the housing price index, and we're merging that with the county data. So housing price index again gives us the prices, and the counties gives us all those FIPS codes, or the county um, where we can get things like the city within the state, right? So much more micro, even population. I don't think I did anything with the population in this analysis, but that'd be interesting too, to see the population changing over time. Maybe that can be a future video. Put that up sometime soon. But the latitude and longitude coordinates are very useful, and actually like uh, indispensable in this case. Like we need that to do some of our plotting. You'll see that in just a minute here. So I go ahead and do the merge, and again, I'm going to use another Plotly chart. I like these choropleth charts. So if you look at choropleth, this is kind of like a heat map, more or less. Let me show you a quick sample here. Plotly have like a geographical heat map, right? So heat maps are useful for a lot of different things. It shows you the concentration or the density of something in one area, or non-density, right? And then once you get the information here, you can create a nice looking heat map, and you'll see at the end how we got that. Okay, so let's flip back here. So that's what a choropleth map does. It's sort of like a heat map for geography. So when we run this, we get the nice details by state with all of the counties all across the United States. Okay, so over here is California, right? San Bernardino, I believe that's the largest county in the United States. And you see over here, this is, I think this is Colorado here. What is that? Michigan over there, Iowa, and so on and so forth. And then you get over to the East Coast, so New York, that's where I live. And if you zoom in, you have excellent detail here of all the counties, right? So that is Jersey, New York City, Queens, that's where I live. Then you have all the counties upstate New York. Okay, so all of this makes sense to me. You always want to do a quick visual check on these things, just to make sure it passes the sanity check and make sure everything looks like it's on the up and up. Okay, so we have the merged housing price information and the merged FIPS data, so we can get the details here of all the counties in the entire United States. So that's pretty cool. And then, of course, because it's a heat map, generally, okay, Delaware is kind of cheap over here, right? Not too expensive, but some of these states like, I guess, New Jersey, Massachusetts, Connecticut, these are darker colors. So the housing prices are higher over here, okay? New York City, it's very high, but I think there's so many upstate that it just pulls down the overall average for the entire state. You can see Texas is kind of high. California is high. That's probably the darkest one, right? So California is pretty expensive, and New Jersey, I'm sorry, Delaware is pretty cheap, right? So that's the takeaway here. And again, this is animated, so when I click on this choropleth map, we can see the changing colors over time. Okay, and if you're very observant, you're going to notice that all of these colors are the same for each state, because I wasn't able to get all of the individual PIPS data like you see over here. Okay, they did have this, but this does give you greater detail within the state, right? Because of course, depending on where you live or where this house is located, like these prices are going to be different all over the whole state, right? So this makes a lot of sense. I couldn't get the changing housing prices over time, right? So this is a PIT point in time map, and this is an animated time series map, right? So they're a little bit different. Same FIPS data, same underlying county demarcation here, or delimitation over here. So you see all the outlines of all the counties, but again, I couldn't find that data that shows you the changing house prices over time by FIP. So we have the static map over here, which is nice. It does what it's supposed to do. It doesn't change. This one changes, but we don't have the individual county by county data, right? That's why these states all look like the same shade of green or yellow or blue. So the next step over here is overall price change analysis. So I wanted to see okay, where are these prices changing the most? Is it Delaware? Probably not. We saw that in a previous map. Is it California? Maybe. So I just wanted to say, or take a look quickly at the differences in price change by place name. So I'm looking at place name, the index for this HPI data, right? Housing price index data, and we're using .diff, right, to get the difference. And you can see pretty easily Massachusetts is number one, right? That is the biggest price change over the time period of analysis. And what was this? This goes, let me see if I open this file. It's sitting on my desktop. Let me just look at this thing pretty quick. Let me see how many years of data we have. I didn't even really pay attention to that the first time. Okay, here's desktop. There's my HPI master. Okay, there's all the data right there. Just quickly open this thing and see what it looks like. Wait, and here it goes. Okay, so we have 1991. Oh, you know what? We can do a quick pivot. Okay, insert pivot in from table or range. Yep, that's what I want. Let me see the years over here. And we have year. So it looks like it goes from 1975 to 2024. So how many rows is that? About 50 years of data. Okay, so it's pretty interesting. So we have 50 years of changing data that we can analyze, right? So that's the FIPS data. Okay, I just showed you that one. Okay, so here's the point. Over the past 50 years, Massachusetts has appreciated the most. And again, some of this FIPS data is at the state level. Some of this is at the city level. So we have Salt Lake City. That is number 2. Miami Beach is number 3. Denver is 4. And then Utah is number 5. And the lowest changes are Shreveport, Louisiana, Montgomery, Alabama, Springfield, Illinois, Puerto Rico, and then Lawton, Oklahoma. So this is appreciated the least, and this one has appreciated the most. Okay. So at this point, we can go ahead and map all of these cities, city by city, because over here, we have all the state data, we have the FIPS data, right? But we don't really have city level data. So I found another data set that I was able to clean up a little bit and then merge together. So now we have city, state population, latitude, and longitude, and the state abbreviation that could come in helpful. I forgot if we actually use that or not. We already have the city and the state. I guess that's because this could be useful. So we went ahead and did some cleaning, merged these two data sets together. So now we have more information. We have place name, price change, city, state, city again. We don't really need that twice, but that's fine. Then the state spelled out, the population, lat long, and then the size value. So again, that was the biggest change that we saw before, right? So I think Utah was number 2, 73641, right? And that's exactly what we see over here. 73641. So that jives. So that gives us peace of mind that we have quick sanity check. Although that's not number 1, right? Massachusetts was actually number 1. But at the city level, then the largest city that appreciated in value, house price value over the past 50 years was Salt Lake City. Okay. So we can use another map. I like these folio maps because these are interactive. You can zoom in, you can zoom out. So there's the city name, right? And we use that to find out where these cities are on the map based on the longitude and latitude coordinates, right? So we see Boise, this is Bend, Oregon, Salt Lake City, and then you see the appreciation. So there's the 73641 again, right? So we can see where these fall on the map. I think that's very useful. If we go over here, we see 73641. So you have the home price appreciation. Everything's plotted on the map. This is very dynamic, interactive. I like that. It looks a little bit like the measles with the color choices over here. Okay. And I saw this. I never heard of this thing before. Barnes Table. That sounds like a very cool name. If my city was called Barnes Table, I would be very proud of that right there. I like that. I like that name. I never heard that before. So that's one way to look at the folio map. I like these Plotly maps too. These are also very interactive. Doesn't look quite as much like the measles. So this is probably a little bit better to go with this one if I was going to get this in front of some stakeholders, I would probably choose this map. And I like the way that they make these changes. This is a red and blue contrast, so you can clearly see the lower appreciation neighborhoods and towns, not really neighborhood, but towns and cities. So you have the size value. Again, that's the house price appreciation over the last 50 years. And then it's corresponding to the redness or the blueness of the map over here. So you can see these are the biggest changes. 736.41. So there it is, Salt Lake City. Again, we have confirmation for this number. And this is pretty close, Boise, Idaho at 627.4. Okay, so those are the biggest gainers in terms of house price appreciation. And probably some of the biggest losers I think we saw was in, what was that, Louisiana, and then Oklahoma. There was one over here, Lawton, Oklahoma, 120.58. Let's see if we can find that on the map. Oklahoma, let's see, it looks like Tulsa. Okay. Oklahoma City, Lawton, 120.58. Okay, so everything jives. So I think we're good there. Again, I like this view a little bit better, but really it's more of a personal preference, which one you go with. And again, we can see the overall state level of house price change, right? So this, again, is PIT. This is a point in time. This is static. This is not an animated chart because it's not over a period of time, but it does show you the total appreciation over 50 years. Massachusetts is easily number one, 988.74, and that should match exactly what we saw over here, right? 988.74, and and what's this now? We go down here, and I think Illinois was one of the lowest appreciation states. So here's Louisiana and Alabama, and so on and so forth. Alaska was over here, and Hawaii is right there. So I thought that was pretty interesting. I thought that was useful too, and I wanted to share that with you guys. And for the last thing here, I'm actually going to do a clustering exercise because I want to see, based on the price difference, you always have to scale these clustering experiments, right? So you have to take all the data because it's going to be skewed upward and downward, and a lot of it is going to fall in between, but you don't want some extreme outlier to interfere with a lot of the more normalized or more centralized data points. So you scale everything, so you don't really like destroy the usefulness of the outlier, because it is interesting to know, okay, this is extremely high or this other is extremely low. You want to know about that, but you want to scale everything just so everything is kind of within the same relative quantifiable scale. I don't like to define the word by the definition of the word, but you tend to usually scale these things to get it more normalized. Okay, so we're doing the scaling of the data, and I am going to look at a quick elbow chart so I know how many clusters I'm going to include here. Let me see if I can run this. Did I get that from the previous? If not, I can go grab that. I think this is saved in memory. Let me see. So with the elbow chart, you look for the biggest bend in the chart. I think it's about 10. That's why I picked 10 over here. So you look for the bend of the chart where it's curving the most. That is supposed to be the ideal number of clusters, right? So it's kind of close to 9 or 10. I'm going to say 10. So I put 10 over here. Okay, so we have 10 clusters, and I do have to print this one too. Okay, so I'm looking at the house price appreciation over time, and then clustering based on that, the change over time, and then assigning that to a cluster so we can see which neighborhoods or cities, not really neighborhoods per se, but which cities are going to be clustered together based on the similarities of the price appreciation. So this one falls into cluster number 5. This is Massachusetts. Salt Lake City is cluster number 3, and similar to Salt Lake City is Miami, and Denver and Utah is that same category. Austin and Boise, Idaho, and then Oregon. Okay, and Portland, Vancouver, Oregon is in cluster number 7, and so forth and so on. Right. So these are cluster 0, and they always start with 0. Python 0 base, so it starts with 0. It goes up to the maximum number of clusters. I said 10, but it's actually gonna end at 9 because we start at 0, right? We don't start at 1 and end at 10. We start at 0 and end in 9. And all these go into cluster number 4. So remember, this one was the cheapest, right? The lowest appreciation. This is similar. This is similar. This. All these are similar, right? So the usefulness of this exercise is you can assign these to clusters and see which cities have appreciated the most. And these will be clustered together, and others that are heterogeneous or different are going to go into their own separate cluster. We end up with a total of 10 clusters. So anyways, I just wanted to show you my findings there. I think this is useful for many different reasons. The housing price index, right, which shows you the change in housing prices over time. The FIPS data, the plotting on the map, the PIT data, the point in time data, so it's stationary, it doesn't change. And then how these animated maps do change over time, right, based on the changing house prices in all these cities. So I think this is a very useful geographical analysis, time series analysis, data frame merging analysis, and just digging into how prices of homes change over time across different regions in the United States, right? So that's it. I'm going to wrap it up now. I'm going to post a video a little bit later today, and I'll see you guys in the next video. Okay, talk to you soon. Bye.